The accurate scale drawing shows the positions of port P and lighthouse L. Alina sails her boat from port P on a bearing of 70 degrees. She sails for 1.5 hours at an average speed of 12 km an hour to port Q. In part 1, we need to find the distance in kilometres of port Q from lighthouse L. So if we have a look, we can see that we'll be given information for time that it will take to get from port P to Q and the speed, but we haven't got the distance. So we can use this formula, distance equals speed multiplied by time, to get the distance. So doing that, if we take the speed, which is 12 kilometers an hour, and multiply the time, so 1.5 hours, that gives us 18. So the distance is 18 kilometers. So we're going to have a look at our scale. So our scale says that 1 centimeter represents 4 kilometers. So since 1 centimetre is 4 kilometres, if I multiply by 18 divided by 4, which is 4.5, so if I multiply by 4.5, okay, here we get 18 kilometres. But because this is like a ratio between centimetres and kilometres, we can do this to this side as well. So multiply by 4.5, well, 1 multiplied by 4.5, so that's just 4.5. So our 18 kilometres on our scale drawing is represented by 4.5 centimetres. So Alina sails her boat from port P on a bearing of 70 degrees. Okay, so for this part you need a protractor, but I can't really get a protractor on here. So I'm going to use this makeshift sort of thing to represent a protractor. So whenever we take a bearing, we take it from the north line clockwise. So we're going to have 0 up against the north line, and we take our bearing this way. So Alina's sailing on a bearing of 70 degrees. So we need to go along our protractor till we get to 70 degrees. So it'll be somewhere near there. I'm going to make a mark there. Okay, so we know that she's sailing in this direction here. But for how long? Well, that's 18 kilometers, and that's represented by 4.5 centimeters. So we're going to draw a line, which is 4.5 centimeters along here. Now, because I'm doing this digitally, I can't get it accurately. But when you're doing it in an exam with paper, you would accurately measure this with a ruler and protractor. So this here is 70 degrees. And the distance here is supposed to be 4.5 centimeters. So it's great. We've identified where port Q is. So now the question says we need the distance from port Q to lighthouse L. So we're going to take a measurement from Q to L. So again, you could do this accurately if you're in an exam on the paper, but you use a ruler to measure this. And you should get that to be roughly 5.5 centimeters. So going back down here, because we got 1 centimeter is 4 kilometers. So like we did before, if we multiply by 5.5 this time, we're going to have our 5.5 centimeters. And if we do the same to this part of the ratio, we're going to multiply by 5.5, and that gives us 22 kilometers. So our answer to part 1, the distance from port Q to lighthouse L, is 22 kilometers. So you get our first mark for the bearing of 70 degrees here. Second mark for using distance as speed multiplied by time to get 18 kilometers here. We get a third mark for then doing the line that's the length of 4.5 centimeters. And the fourth mark for the final answer of 22. Now for the second part, it wants the bearing of port Q from lighthouse L. Okay, so remember we always take a bearing from the north point and go around clockwise. So in this case, because we go around clockwise, we want this angle here. That will be the bearing that it wants. However, because our protractor only goes up to 180 degrees, it's a bit more difficult to work this out. So we can use a little trick. If I extend this line down here, we should notice that this is an angle on a straight line. So this is going to be 180 degrees. Therefore, we just need to measure this angle and add on 180. And I'm going to rotate that round. And we put that on this line here. So measuring from 0 round, you should get something similar to 140 degrees. So our bearing of port Q from lighthouse L is our 180 degrees plus the 140 degrees we measured with our protractor, giving us 320 degrees. And that's our final bearing here. And it's important to point out that in this question, because we're measuring things, everyone's measurements and diagrams can be a little bit different, so you get a bit of leeway. So a few kilometers around this number or a few degrees around this, and you still get the mark.